There are three methods of supplying liquid refrigerant to an evaporator: direct expansion, or DX, gravity-fed, or flooded, and pumped overfeed, or recirculated liquid. Direct expansion, or DX, is the simplest form of liquid supply. In DX evaporators, liquid is supplied through an expansion device directly into the evaporator, hence the name direct expansion. As the refrigerant absorbs heat in the evaporator, it boils as it transitions from a liquid to a vapor. DX evaporators are designed so that all liquid boils inside the evaporator. The final portion of the evaporator will only contain refrigerant vapor, which will become superheated as sensible heat is absorbed. Designing DX evaporators in this way ensures that no liquid is supplied to the compressors. The main advantage of a DX evaporator is its simplicity, which typically results in savings when designing and installing a system. The downside is that a measurable portion of the coil is not exposed to liquid refrigerant, which reduces the overall capacity. Therefore, DX evaporators require more surface area than gravity-fed or pumped overfeed equivalents. A gravity-fed or flooded evaporator is designed so that the liquid leaving the expansion valve is piped into a vessel called a surge drum or accumulator. The surge drum is located above the evaporator, which allows the low-pressure liquid from the vessel to be fed to the evaporator by gravity. As heat is absorbed in the evaporator, the liquid will boil, forming vapor, which is returned to the surge drum. The vapor rises to the top of the surge drum, where it is piped to the compressor. Flooded evaporators are employed in part so that the flash gas formed through the expansion device never passes through the evaporator. Instead, the flash gas enters the surge drum and is returned to the compressor. This means that 100% liquid is supplied to the evaporator, which is preferable. Another advantage is that when multiple flooded evaporators are installed in the same system, they can be controlled at temperatures and pressures that are independent of each other. This allows for precise temperature control in different rooms, which is ideal for the fresh produce industry. The downside of flooded evaporators is that because each flooded zone requires a surge drum, the systems are more complex and expensive than when using direct expansion. A pumped overfeed or recirculated liquid evaporator is similar to the gravity flooded in that it utilizes a vessel that was not part of the DX system. In a pumped overfeed evaporator, however, the vessel, often called a recirculator, is not located above the evaporator. In fact, the recirculator may be a long distance from the evaporator. Instead of using gravity to supply liquid to the evaporator, the recirculator will have a pump connected to the bottom of the vessel, which will move the cold liquid refrigerant from the recirculator to the evaporator. The pump will typically supply more liquid than will evaporate, hence the name pumped overfeed. The ratio of the liquid fed to the evaporator to the amount of vapor formed is referred to as the recirculation ratio.
One of the ways that we characterize a pumped overfeed system is by the recirculation ratio. Okay, and what is the recirculation ratio? It's really quite easy to understand. It's the ratio of the amount of liquid that the pump is moving to the ratio of the vapor that's formed inside the evaporator. So here I've drawn a simple recirc system, or part of one. I've got a recirculator here with a liquid level, a single pump, and it's moving liquid through an evaporator, and then that's getting returned back to the recirculator. That's what's happening here. And I've stated here that it's pumping 40 pounds per minute. All right, that's the GPM converted to a mass flow rate of that pump. And then in the evaporator, as heat is absorbed into the refrigerant, 10 pounds per minute of vapor is formed. So that's the actual refrigerant needed for our refrigerating effect that needs to be vaporized, which means, because our mass has to be conserved, we have 30 pounds per minute of liquid still. So the sum of that, 30 plus 10 is equal to 40, so there's no net gain or loss in the mass flow rate. So the recirculation ratio is simply the ratio of the total amount of liquid pumped to the vapor formed. Okay, so the math here is pretty simple, but I'll write it on the board anyways. We take our 40 pounds per minute and divide that by the vapor formed, 10 pounds per minute. That equals 4, obviously. These units will cancel. And often the way this would be displayed or even spoken would be as a ratio of 4 to 1. So the recirculation ratio in this example is 4 to 1.
As with the DX and flooded evaporators, the liquid will boil inside the evaporator. Vapor formed in the evaporator is returned to the recirculator, where it is separated from the liquid and rises to the top of the vessel. The same recirculator can be used to supply multiple evaporators. For this reason, using pumped overfeed evaporators is less expensive than flooded evaporators.